Hi. We're looking at multiple regression. Next, we're going to learn about dummy variables. We use dummy variables if we have a categorical dependent or independent variable. Okay, so let's say we want to look at a relationship between some amount of money spent and gender or state of origin. Gender and state of origin are variables that we can't really quantify. They fall into different categories. So we use dummy variables to use them in regression to take a look at how they affect outcomes. Right now we're looking at a problem on restaurant ratings. This comes from Anderson 11E, chapter 15. It's question 37. I'll read it first. The Consumer Reports Restaurant Customer Satisfaction Survey is based upon 148,599 visits to full-service restaurant chains. Assume the following data are representative of the results reported. The variable type indicates whether the restaurant is an Italian restaurant or a seafood steakhouse. Price indicates the average amount paid per person for dinner, and drinks minus the tip. Score reflects diners' overall satisfaction, with higher values indicating greater overall satisfaction. A score of 80 can be interpreted as very satisfied. Well, let's look at the data first. Okay, so here you see the data. That's on the second tab. I use Control Page Down and Control Page Up to switch tabs, but you can also click on the tabs. Here you see we have restaurants, Bertucci's, Black Angus Steakhouse, etc. We have them. There are different types. We have a type column here. And then we have the price and the score they received from consumer reports. Okay, so we're going to be using this data. You can see that it goes down off the. I can zoom out so we can see the whole data set. It gets kind of tiny there, but yeah, it goes down past the page. So just make sure we know where it all is. Question part A is asking us to develop the estimated regression equation to show how overall customer satisfaction is related to the independent variable average meal price. Okay, so we want to know about customer satisfaction. Let me pull out my ink here. I want to know about how overall customer satisfaction, which we measure with a score, how overall customer satisfaction is related to average meal price. And they're telling us that the average meal price is going to be an independent variable. That means meal price is going to be the x. Okay, now in order to look at the estimated regression equation, we need to go over to our data and run a regression. Okay, so we're going to regress score on price to see how the two are related. To do this, we go up to our data tab, go over to our data analysis. If you don't see it, you need to enable your data analysis tool pack. One of my videos shows you how to do that. If you do see it, good. Okay, that pulls up this data analysis panel. We scroll down to regression and select that and click OK. All right, now we have a bunch of things we need to put in. First, we need our y's. That's our dependent variable, our outcome, variable of interest. Click that, and that's going to be our entire score. I'm holding Shift and pressing down. If I hold Control while I press down, it selects the whole thing. Alternatively, you can click and drag, but you can see that it's a little wonky. So Control Shift down is the fastest way to do this. For the x's, select that. Click here, hold Shift and Control, press down, and it automatically selects the whole thing. You can see that what I'm looking at here is C1 to C22, right? That's that whole column. Goes from C1 to C22. I've included labels, right? So price is included in that, so I need to click this label section. What else do I want? That's it, really. I just need my labels. We're not looking at residual plots yet. We'll get there soon. And I'm going to name this score equals price, which is just saying that score is being regressed on. Score is on the left side, price is on the right side of my equation right now. Click OK. And there we go. Here's our output. I can double-click this to make it a little bit wider. And this shows our relationship. Okay, what do we see here? Well, we have some. We have our intercept right here. So this is B0, and this is B1. What we've done right now is we've estimated this model. We've estimated score equals beta 0 plus beta 1 times price plus epsilon. That's our error term. So we just estimated that model. And we did that by creating a B0 and a B1. And that's what these are right here. Excel did the heavy lifting for us. And we have our coefficients right here. That's B0, that's B1. We can use this to finish part A. So part A was asking us to develop an estimated regression equation. And if you remember, estimated regression equations always look something like this. Y hat equals beta b0 plus b1 times x1. That's an estimated regression equation. So go over here to my answers. And what I'm going to be writing here is, let's see, we have estimated score. So score hat equals, and then I can scroll up. Oops. 69.276. So I'm getting that number from right here. B0. So right there, 69.276. And I can write that in here. Where's my pen? There we go. 69.276 plus 0.5586 times price. So that's my estimated equation. 0.5586 times price. That's my estimated equation. Okay, that's just simple linear regression. That's nothing terribly new from what we've done before. Part B is where Part B is asking us to test whether the estimated regression equation in Part A indicates a significant relationship between overall customer satisfaction and meal price. In Excel, it's easy to do this because we can look at the output that they give us. So it's asking us if there's a significant relationship between our score and our price. In order to do that, we just look over here. We have our coefficient, our standard error, our t-statistic, and then this is the important thing, our p-value right here. So if our p-value here is less than alpha, then we're going to reject the null that there is no effect, or that there is no significant relationship. So this 0.05, that's what we care about. That's our p-value, and that's really small. So for part B, the null is going to be beta 1 equals 0. Our p-value is equal to 0.005 or 205,182. And so we can reject the null. That means there is a significant relationship between price and score. It's a positive relationship, actually, which is kind of strange. I mean, I guess it makes some sense. But we're not holding other things equal. So what this is essentially saying is that more expensive meals are more satisfying in general. That's the relationship, which I guess it's a good thing. Okay, now the next thing we want to do is Part C is asking us to develop a dummy variable that will account for the type of restaurant. Now, a dummy variable is going to look something like this. Let me do it over here. So we're going to define D2, which is equal to 1 if it's an Italian restaurant, 0 otherwise. You can also define it the other way, and I'll show you a few ways to do this quick. So in Excel, we want to do this. I'm going to insert a column here. I want to keep it next to my price because we're going to want our x's all to be together. One way to do it is just to go down and say, oh, that's Italian, so that's 1. Seafood and steakhouse, 0, 0. Italian, seafood steakhouse. You can do it that way by eyeballing it. Another way you can do it is you can sort the data. If you select all the data, you can go up to Data, Sort, and tell it that your data has headers, and then sort by type, and it automatically sorts it. You can see, puts all the Italian first, and then seafood steakhouse next. So you can go 1 1 1 1 1 1 1 1 1 1 1, and then 0 0 0 0 0, and that's our dummy variable. The way that I'm going to do it is I'm not going to sort. You'll see what I'm going to do is like this. I'm going to create a new formula here. Equals if, and then this is a logical test. B2 equals Italian. 1. If it's true, 0. The value if false is what I'm entering now, 0. So if it's Italian, if I copy this and paste it, you can see I'm just pasting, Control V, Control V, Control V, all the way down. And now I have a dummy variable. I can call this dummy, although that's not very useful. You can call this Italian or little d Italian. That little d tells me that it's a dummy. And I'll put an underscore there to make a space. It's a dummy that's 1 if it's Italian. That's an easy way to see it. So that satisfies part C. On a test, you could put this something: define D2 equals 1 if it's an Italian restaurant, 0 otherwise. For now, since I'm in Excel, it's easier to do it that way. Part D, develop the estimated regression, and then part E, is it significant? We're going to do that pretty straightforwardly. We could go back to our data tab, click data analysis. We have our regression. We need to make sure that our inputs are correct. Our Y, again, is score. And our X now is going to be both of these. We're going to include the dummy and the price. So we have C1 to D22. We still have labels. And now I'm going to add this to the name. Score equals D Italian price. That way I know that I have one left-hand side variable is score and two right-hand side variables is price. Click OK. And here you go. I have my output. So I can develop my estimated regression equation. Just it's going to look like this. Y hat, which is the predicted score, is going to be 67.404. I'm getting that from the intercept right there. Plus 3.038 times Italian dummy. Plus 0.5734 times price. And that's my estimated equation. Easy enough. I'm just pulling these, the coefficient column right here. So these three numbers are the numbers that I'm putting in there. Those are my B's. And then part D is asking us if there's a significant relationship between Italian and between Italian restaurant, the type of restaurant, and the score. We can see that there is. This p-value right here is 0.017. So it's not, if alpha equals 0.01, we would fail to reject the null because it's higher than that. But for most alphas, right, 0.05, the most common, we would reject the null. There seems to be a relationship. We can quantify that relationship. Italian restaurants seem to get a 3-point boost in score, all other things equal. Why is that? Well, it might be that holding price constant. I mean, it looks like holding price constant. Italian food is more satisfying. Maybe that's because pasta's cheap, and so you can get an equally satisfying meal made with pasta in it. Maybe it's because Italian decor is preferable. Who knows? All we know is that there's a positive correlation. So without any, I'm going to cut it short there. You can do part F yourself. Just plug in $20 to the meal price and look at the differences between Italian restaurants and seafood steakhouses. But I'm running short on time, so I'm going to finish it up there. Stay tuned. I'll do some more stuff soon, so you guys should have more videos to watch. Thanks. Bye.